So it is time for us to go ahead and write a unit test for our simple calculator application. The way we're going to do that is by going to our solution, right-clicking on it, choosing Add New Project, and then going and typing in Test, choosing Unit Test Project, and then we're going to name our project Simple Calculator .test.unit. So before I click OK, I want to talk about the naming. The reason why I said .test.unit is because by .test, we're trying to say that this is a testing project, and by .unit, we're trying to say what type of a test it is. There are many types of tests, such as acceptance tests or integration tests. We're not going to go over those, but I want you to know that there are other types of tests. And as you're writing more and more tests, creating more and more projects, as you add them in this way, Solution Explorer is going to organize them alphabetically for you. So whenever you're looking at the project and you're trying to find the one you want, it's going to be a lot easier to find it. So that's the reason. So simple calculator.test.unit. And we're going to say OK. And you can see this is the default class name and the default method name. We're going to change the class name, and the rule of thumb is to change it to the class name that you're trying to test and then add test right next to the name. So in this case, I'm going to test calculator engine, and I also want to test input converter. So let me go ahead and copy the calculator engine, which is the one that I'm going to test out first, and right click, rename, and then add tests right next to the name. And say yes, that changes the name here. And then the rule of thumb for naming the method in your test class is by naming it to the feature that you're trying to test. So for example, if I was trying to test the addition feature for non-symbol operations in my calculator engine, I would name it something like this: adds two numbers and returns valid result for non-symbol operation. So you're telling the feature that you're testing. And there are many other different ways in which you can name your test methods, but this is one way which is very straightforward and intuitive. And I usually follow this. So let's actually go ahead and do that. We're going to rename this method. I'm going to say adds two numbers and returns valid result for non-symbol operation. There you go. So now, before we even write our unit test, I want to tell you about the 3 steps of writing a unit test. There are 3 steps. First step is setting up the data for your unit test. Second is processing that data through the method that you want to test. And the third one is comparing the result that you got from the processing against your assumption. So let me show you how it's done. I will say int number 1 equals 1, int number 2 equals 2, then I will say double result, and then here's where we're going to stop and take a look at this. So these 2 lines, when I'm saying number 1 and number 2, this is me setting up the data. So I'm saying, hey, I have 2 pieces of data. I have 1 and 2. Now I want to process this data. But for processing, we actually need to access the calculator engine. But how do we access the calculator engine if we're in another project? So in order to do that, we need to add Simple Calculator as a reference for a Simple Calculator test unit project. So in other words, Simple Calculator.test.unit is going to be dependent upon Simple Calculator. The way we do it is by right-clicking on the reference, clicking Add Reference, and then choosing the dependency in here. So if there are other projects and we want it to be dependent on them, we could choose them too. But in this case, it's Simple Calculator, so we check that and we say OK. So see here, it has many other ones, not many, it has 3, but we have Simple Calculator as well, and that's the one we needed. It also has Microsoft Visual Studio Quality 2's Unit Test Framework, which is the default testing framework for Visual Studio. But that's been added automatically when we created our test project. So now we can go ahead and we can access Calculator Engine. I'm going to go ahead and say private, read-only, Calculator Engine. See, we have access to it now. And I'm going to rename that, and I'm going to initialize and say Calculator Engine like so. And then we're going to actually use that. We're going to use the method calculate. And I'm going to say, since it's non-symbol, I'm going to say add. And then I'm going to say the first, or rather the second parameter is number 1, and the third parameter is number 2. So now we have our processing in place as well. Third step is for us to compare the result against our assumption. So we can do that with a pre-written class and pre-written method called assert and arequal. So assert is the pre-written class, and on it, it has many other methods, but one of them that we're going to use is arequal. This says, I will take an expected result and an actual result, and if they match, then the test will pass. Otherwise, it will fail. So what is our expected result? Our expected result is 3, because we're adding 1 to 2, so we're expecting it to return 3. But the actual result is going to be the result that gets returned from our processing. And then we're going to compare them. So if this passes, the test will pass, otherwise it will fail. We can actually do another unit test here, and this one is going to be for symbol operation. So it's going to read as adds 2 numbers and returns valid result for symbol operation. In this case, all we need to do is change this to plus, and that should do it. So the way we can run these tests is by going to test, run, and then all tests, and we can just click that. So this will run all of our tests, and then we can go to test windows, test explorer, and see what has run and what has passed and what has failed. In this case, we have 2 unit tests and both of them passed, and we can actually lock it in here so it doesn't go away. The beautiful thing about this is that if somebody makes a mistake, for example, if somebody goes into the calculator engine and for whatever reason they're working on it and it's late night and they're very tired and for whatever reason they change this plus to minus, what can happen is they can then run the unit tests like so. And when they run the unit tests before checking in their code, they'll see that something is wrong because everything broke. So they'll say to themselves, what happened? So then they can actually go ahead and debug their code. So they'll do something like this. They'll just put a breakpoint and then they will go to test and debug and all tests. And when it comes down to this line, it'll say, okay, let me process the data. But the result is -1. So 1 plus 2 shouldn't give you -1. Something's wrong, right? So then they will stop that and they will go inside of that and try to troubleshoot, and they'll realize that it's actually minus. So this should be plus. So when they see that, they'll fix it and that'll keep the code accurate. And the only reason why that happened is because they had unit tests in place. And they can run it again, see everything pass. And you see that it passes now because it is what has been expected and what has been returned, they match up. Another thing is that you can see here, I'm using read-only. The read-only reserved keyword we're going to be going over later. All you need to know is that whenever I'm trying to use the class that I can then use methods from to do the processing part, I basically declare it globally here. And then off that, I use the methods like so, calculator-engine.calculate, calculator-engine.calculate. The other part of the unit testing beauty is that we could have had a lot of other unit tests for multiplication, subtraction, division. In this case, I'm just keeping it simple and I have 2 unit tests. However, if we wanted to, we could have covered a whole range of possibilities. And that is the beauty of unit testing, because you don't have to go through each scenario manually. You can write all of the scenarios, put them in place, and then as you're changing your code, you can feel safe that if anything goes wrong, your unit tests will catch it for you. Okay, so now let's go ahead and write another unit test. I will go to Solution Explorer and I will right click. I will go to add new item and then I will say test. I will choose basic unit tests, and in this case I'm going to be testing the input converters. So let me actually close that and grab the name so it's the correct name. Go back again and now I will say add new item. Once again, type in tests and choose basic unit tests, and then the name should be the name of the class that we're trying to test, and test at the end. You see, once again, it's in here. And the name of the method I'm going to say it's going to be converts valid string input into double. So let's go ahead and do that. Converts valid string input into double. And I will go ahead and set up my data. I will say input number is 5, so it's string. Then I'm going to say converted number is equal to, and now we still need access, right? So in this case, we already have a reference to simple calculators. So all we need to really say is private read only and input converter. We already have access to it. And name the variable. And in this case, I'm just going to copy paste again, just to be consistent, and then new and input converter. And that should do it. So now we can use this for our processing, and we can come here and say convert input to numeric, and then pass in the string, so the data that we have set up for our unit test, input numbers or input number. And then say assert dot are equal. And remember, first is our expected and then our actual. So our expected is 5. The actual is what's going to be returned. So we are going to then pass that in here. And if it matches up, then it's going to pass. Otherwise, it's going to fail. So let's build this one more time. For some reason, I undid that. Let's bring it back again. And build. And see, it added it here. So let's check out in here. Looking good and looking good. So let's run it. So it passed as well. Beautiful. So now I'm going to write one more unit test. This one is going to be a little different. It's not going to have an assert. This one is going to actually check if we're throwing an exception. So the name of this is going to be fails to convert invalid string input into double. Let me go over the name. Fails to convert invalid string input into double. Great. Now the input number is going to be a symbol, something that just won't convert. We're going to convert it over. It's going to fail. Then we're going to say, we're going to put another attribute here. And the attribute is going to say expected exception. These are attributes, by the way. And so here I'm going to say expected exception. And what this is going to say is, it's going to say, I'm expecting a certain type of exception. So if we go here, you see this is throwing an argument exception. So I'm saying this unit test has to throw an exception, and that exception has to be of type argument exception. If that is not the case, fail this unit test. So once again, I'm going to build this up and I'm going to run this. And you see, everything passed. Now, if I actually turn this into a valid number, this will pass, but the unit test won't pass because it's expecting a failure. So I'm going to run it one more time. And you will see that it actually failed. If I turn it into something that will throw an exception, it will pass. See that? So there you go. That was just another different type of unit test. And one more thing before we end the video, there's actually a typo in the input converter. So I'm going to go ahead and fix that. I'm going to right click, or rather Control RR, and I'm going to rename it to convert input to numeric as opposed to saying numeric. So that was just a typo. So numeric, and we're going to change that and save it and also build it. And you can see that it changed the name in the input converter test as well. Convert input to numeric. And everything is looking good. I'm going to build it one more time and run the test just to make sure everything runs. And there you go. Everything is looking good. This is unit test. I hope you liked unit test. Please do use unit test because it's going to make you into a better developer. It adds a lot more value to your portfolio. And it's also going to help you out whenever you're trying to debug and find issues in your code. It's actually going to prevent you from having issues in your code as you're writing new features and maintaining existing ones. That's it for now.